The knock sensor, also known as the detonation sensor, or by its English abbreviation KS, knock sensor, is responsible for monitoring abnormal detonation events that occur in the engine during each combustion cycle. This information is sent to the Engine Control Unit, ECU, which adjusts the ignition timing in order to optimize combustion efficiency and protect the engine from damage caused by pre-ignition or detonation. When the sensor is faulty, the ECU may incorrectly adjust the ignition advance, resulting in inefficient combustion and multiple failure symptoms that may be confused with the malfunctions of other sensors. In simple terms, this sensor detects the vibrations generated by the explosions inside the combustion chamber. If it identifies excessive or irregular detonation, it modifies the ignition timing to keep the engine operating within safe and efficient parameters. Generally, the knock sensor is mounted directly on the engine block, near the cylinders. In V-type engines, such as V6 or V8 engines, it's common to find two knock sensors, one for each cylinder bank. Symptoms of a faulty knock sensor: engine knocking or pinging, loss of power, slow acceleration or delayed throttle response, increased fuel consumption, unstable idle, detonation or backfiring during acceleration. To perform measurements on the knock sensor, you should know that it normally has two wires whose functions are sensor ground and output signal. In some models, it may have only one wire, since the ground is obtained directly through the metal body of the sensor, which is in contact with the engine block. There are also three-wire sensors, where the third wire is used as shielding or reference to reduce electrical noise in the signal generated by the sensor. An important fact is that this sensor does not receive direct power from the ECU, since it operates using a piezoelectric element. Each vibration produced by detonation generates a voltage proportional to the intensity of the impact. That is, the stronger the detonation, the higher the output voltage, and the weaker the detonation, the lower the voltage generated. Basic knock sensor test. To check its operation, you must use a multimeter set to the 20 volts DC scale and place the test probes on the sensor terminals. Then, using a small metal object, such as a hammer, gently tap the body of the sensor. With each impact, you should observe a voltage change on the multimeter. The harder the impact, the higher the voltage generated. If the sensor produces a signal with each impact, it's considered to be operating correctly. If it does not generate voltage or the signal is unstable, it will need to be replaced. Another common fault related to this sensor is wiring damage. To verify the condition of the harness, electrical continuity must be checked from the sensor connector to the corresponding pin at the ECU using the vehicle's wiring diagram. If an open circuit, short circuit, or excessive resistance is detected, the wiring must be repaired or replaced. If you would like to learn more about how engine sensors work, I invite you to watch the following videos where you will learn how to identify failure symptoms, reference voltages, and diagnostic methods for the main sensors and actuators used in your vehicle.